I'll just talk about two different outcomes. I'll start with outcome one. I'm going to share my screen. In aerospace engineering, we defined, we interpreted learning outcome one primarily in terms of problem-solving skills, and in particular, an ability of students to define, formulate, and solve open-ended problems. I've been influenced a lot by Don Wood's problem-solving methodology. Don Wood is a chemical engineer at McMaster University, and he has published a lot on problem-solving. And so we pretty much follow his methodology in guiding students on how to tackle open-ended problems. So we took basically the 6 steps of his problem-solving methodology and defined them as the performance criteria for that outcome. So the first step, or the first skill, performance criteria is actually a skill you try to measure, right? Is ability to define a problem in proper engineering terms, so you can actually measure it, calculate something, and answer the question. The second criterion is explore the problem, and that means decide how you're going to model it, what assumptions are reasonable to make, et cetera, et cetera. The third step is develop a plan for the solution, which means write down the equations you need to use, which are appropriate for the models that you decided, in step 2. Step 4, or performance criterion 4, is the implementation of the solution plan, which is basically plug and chug the numbers. And after you do the calculations, make sure that you double check and that they're accurate. Step number 5, or skill number 5, is evaluate the results. So you got a bunch of numbers. You need to sit down and reflect on whether these numbers make sense, whether the assumptions that you made earlier have affected the accuracy. Is there anything else you can do, to improve the outcome, et cetera, et cetera. And the last skill is we ask the students to reflect individually on the personal strengths and weaknesses that they feel exhibited in applying the problem-solving methodology. So I will share the rubric in a minute, but before I switch from the PowerPoint to the PDF, I will also show you the learning outcome 6 skills or performance criteria. So when we read the learning outcome 6, we kind of identified 4 separate elements in the outcome, which we felt required different sets of skills and different ways of measuring. The first part is the ability to design an experiment. The second part is ability to conduct an experiment. And then the third part, ability to analyze the data. And finally, ability to interpret the data. Ability to design the experiment, we broke it down into 6 steps. Actually, this is an old project of ours. I think Buff was involved in this, Buff Furman from Mechanical, Winston Du, Thalia was involved in this, Claire Comivis, and we probably have not changed these steps, very much since that time. So the first step is define specific goals and measurable objectives for the experiment. What do you want to measure? Research any relevant theory and publish data from similar experiments. Select dependent and independent variables. Select appropriate methods for measuring and controlling each variable. Select a proper range for the independent variables. And finally, determine an appropriate number of data points that you need to collect in the process. For the second element, ability to conduct the experiments, I will confess that we have not been measuring that. We've been doing a pretty good job on the other 3 elements, and this one is kind of hiding in there. But what we're going to do moving forward is ask basically the instructor. We have to create a rubric for that and ask the instructor to observe the students on how well they exhibit familiarity with equipment, how well they calibrate the instruments that need to be used, and whether they follow proper and safe procedures, to collect the data. The third element, ability to analyze data, we broke it down into two sets, ability to carry out the necessary calculations and ability to plot the results using appropriate choice of variables and software so you can display them in a clear fashion. And finally, the last part, and perhaps one of the most important, along with the first one, in my opinion, is the ability to interpret the data, which is making observations and drawing conclusions regarding the variation of the various parameters involved. And the second performance criterion related to that is compare with theoretical predictions and other published data. And if there are any discrepancies, explain, why you have these discrepancies. So I'm going to jump now into the rubric for problem-solving skills. But here I'm showing basically the rubric, which involves 6 different rubrics, actually, one for each skill or one for each step in the problem-solving process. So as you can see here, with the traditional rubric, there is quite a bit of work that goes up front because you have to describe as accurately as you can the performance that you expect from the student for each grade. So for a perfect 10, identify a proper measure. I have to measure the pressure, include appropriate sketches illustrating all relevant parameters. So we emphasize, graphical representation of the problem. And then you have to describe, okay, how do you get a 7 or an 8? How do you get a 5 or a 6? And how do you get from 1 to 4? So I did that about 10, 15 years ago for each step or each skill, explore the problem, plan the solution, implement the solution, and evaluate the results, and finally the personal reflection. In the past year or so, I have become familiar with specifications grading and mastery learning. In fact, we have here a couple of people who are a lot more experienced in that than I am, probably Nicole and Maria. And that opened my eyes to simplify the rubric. And instead of having 4 or 5 points on the scale, you can just pick the best performance of each step and call that meets the criterion. So for example, for the first skill or the first performance criterion, we expect the student to define 1 or more measures for answering the question if one is not explicitly given in the problem statement. I elaborate on this a little bit more for the benefit of the student, identify a proper measure, include appropriate sketches illustrating all the relevant parameters. So as I read their solution, I either give them 1 or a 0. 1 it means it meets the criterion, 0 means it needs revision. And of course, you do have to write comments and explain, why it doesn't meet the criterion. How can the student go back and rework on this and do better the next time. So basically, this is the simple version of specifications grading, where you have basically a 2-point scale, either meets the criterion or needs revision. And if you want a little bit more resolution, you can have a 3-point scale, a high pass and a low pass for the meets criterion, and the needs revision. And again, this is primarily for assessing the skills and deciding what the student does well and what they don't do well, so you can give them an opportunity to go back and redo. If you want to translate that into grades, I have an example down here. If, let's say, you want to give the student an A+, they have to have a high pass on all 6 of the performance criteria. If they have a high pass in 5 of the 6 and a low pass in the remaining 1, then you give them an A. If they have high pass in only 4 out of the 6 and a low pass in the remaining 2, then that's an A-. And you can go down from there, however you see fit. So this is the rubric we use to grade lab reports. And you can see that in addition to assessing outcome 6, which is lab skills, we can use the same rubric basically to assess communication skills. We have abstract, we have references at the end. Okay, I'm not going to talk about this. The important thing is, and this is what we're working on right now, is to make sure we have a one-to-one correspondence between our rubrics and our performance criteria. So for element 6.1, which is the design of experiments, here are the steps. Design specific and measurable objectives for the experiment, research summarize theory, etc., etc. For element 6.3, presenting the results, here is basically the statement. And for element number 4, which is basically graded through the discussion of the results, then we're using again a scale of high pass, low pass, or needs revision. So I'm going to stop here and open up the floor for questions that you may have.